quickly identify the subnet that the IP 192.168.201.40/28 belongs to. The fastest way to tackle this problem is to work out the network IDs and then figure out which network ID that IP falls within. Let me show you what I mean. 192.168.201. Now, we're tempted to turn 40 into binary, but we actually don't need to do this. Let me just write out the last octet here as x's. 1, 2, 3, 4, 5, 6, 7, 8. /28, what is that covering? Well, that is covering the first 3 octets. This is 24 bits, 25, 26, 27, 28. It's covering up to that bit there. Now, if we were subnetting this, what we would have said is that this bit here is the increment value. In this case, the value of that column is 16. So using that information, I could actually back out the original network IDs. The original network IDs were 192.168.201.0. How do I know this? Well, the original network ID is class C. Class C has a default prefix of /24. Therefore, the original network ID must have been 192.168.201. So this is the original network ID. When they subnetted this, they used a prefix of /28, and the increment value was 16. Therefore, we can calculate the network IDs that they worked out by incrementing the 4th octet by 16. So the original network ID was 192.168.201.0. This is all using /28. The next one is 192.168.201.16. The next one is 192.168.201. 16 plus 16 is 32. And the next one is 192.168.201. 32 plus 16 is 48. Now I'm going to stop right there. I'm going to stop right there because the number we're looking at is .40. .40 is right in between 32 and 48. Therefore, what that means is .40 is actually an IP address from the network ID .32. .32 has a range of values from .33 all the way to the next network ID is 48. 47 would be the directed broadcast of the 32 network. 46 would be the last valid IP address. So the range of values for the 32 network would be 192.168.201.33 to 46. .40 is within that range, therefore it is from the 32 network. So to recap, what I did is I reverse engineered their subnetting. I actually calculated the network IDs, or at least a few of them, that they originally calculated. The IP address is class C. The default prefix is /24. That covers the first 3 octets, so the original network ID was 192.168.201. I write that out here. They're using a prefix of /28. If I were to write out the original network ID and just put X's in the last octet, and then look at what bits are being covered by 28, this is the last bit that's being covered. That is therefore the increment value. I'm therefore incrementing the last octet by that increment value. And I'm looking for where this IP address fits in. That IP address fits in between .32 and .48. Therefore, that IP address is part of the .32 subnet. This is the fastest way to work this out. The alternative to this approach would be to convert 192.168.201.40 into binary. 192.168.201. What is 40 in binary? Well, if you have a calculator, you can do this quickly, but in an exam like CCNA or MCSA or even Network Plus, you would not have a calculator. So how do I convert 40 into binary? Well, this would take a lot more time than the previous approach, which is why I prefer the previous approach. But what we have to do here is simply divide 2 into 40. We have to do this repeatedly. So 2 into 40 is 20, remainder is 0. And there we go. And I could just write this out now. So this all goes there. 1, 0, 1, 0, 0, 0. But wait a minute, this is not 8 bits. This is 1, 2, 3, 4, 5, 6 bits. So I have to pad it with 2 zeros. So in binary, 40 in binary is 0, 0, 1, 0, 1, 0, 0, 0. It didn't take forever, but my prior method actually I think works a bit faster. In any event, /28 covers all the way from here to here. It's covering these 3 bits in the 4th octet, so that works out to 192.168.201 and the value of these 3 bits is 32. This is the 32 column.